Hi everyone, welcome back to Python Code Nemesis. In today's video, we'll be reading about abstract repositories in Python, which is something that we also implement in the domain-driven design pattern in Python. So let's get started. What is an abstract repository? An abstract repository is a design pattern commonly used in software development to decouple the application logic from the persistence layer. We did talk about abstract repositories in short in one of the previous videos on dependency injection. So if you haven't looked at it, you can take a look at that and come back. An abstract repository defines a set of interfaces or abstract classes that provide a common API for data storage and retrieval operations. This allows the application to be more modular and flexible, as different implementations of the repository interface can be used depending on the specific storage mechanism. For example, a SQL database, a NoSQL database, or an in-memory cache. ABC module. The ABC module in Python stands for Abstract Base Classes. When you import ABC from this module, you can use it as a base class for your abstract classes. Abstract classes cannot be instantiated directly, but are instead meant to be subclassed by other classes that implement their abstract methods. By defining abstract methods in your base class, you can specify a set of methods that any concrete subclass must implement. This can be useful for enforcing a specific API or behavior across different subclasses, or providing a common interface that other parts of your code can use. Why do we use abstract repositories? We create abstract repositories to decouple the application logic from the persistence layer. By defining a common API for data storage and retrieval through an abstract repository, we can switch the underlying implementation of the repository without affecting the application code. This allows for greater flexibility, modularity, and maintainability of the code base. Here's an example of how you could define an abstract repository in Python using the ABC module, which is the abstract classes module. So from ABC, import ABC and abstract method, defining an abstract class called abstract repository that inherits from ABC. Use this decorator abstract method to define an abstract function, def add self comma chocolate box. This method will be implemented by the concrete repository. Similarly, the get method will also be implemented by the concrete repository that inherits from this abstract repository. Similarly, another method to remove. This is basically a simple class to with functions that initialize the chocolate box, like add chocolates to the chocolate box, get chocolates based on the ID, and remove chocolates. So in this example, abstract repository is an abstract class defining three abstract methods: add, get, and remove. These methods are placeholders that must be implemented by any concrete subclass of abstract repository. By defining this abstract class, we can ensure that any repository implementation will provide a consistent API for data storage and retrieval operations. Here's an example of how you could create a concrete repository class that implements the abstract repository interface. Defining a concrete repository class called in-memory repository that inherits from abstract repository. There's the init function, which defines a constructor, add, which adds some data to the chocolate box. So chocolate box dot ID. So whatever our object is sent, the ID is equal to chocolate box. So that is initialized to this, and there's also a get based on the ID and a remove. So deletes that entry for that chocolate box ID. So in this example, we used in-memory repository, which is a concrete repository class that uses an in-memory dictionary to store data. Something that we do a lot so that our DB tests or integration tests can run on the pipeline without requiring a database connection. It implements the three basic Abstract methods, add, get, and remove. Implementing these methods in-memory repository provides a concrete implementation of the repository API that other application paths can use. By using an abstract repository, we could easily switch out the implementation of the repository without affecting the rest of the application. For example, we could create a new repository class that uses a SQL database instead of an in-memory dictionary. The application code that uses the repository wouldn't need to change. Create a mock repository that uses Postgres database. First, we'll need to install psychopg2, so do that with pip install psychopg2 binary. Next, we'll define our Postgres mock repository class, which will implement the abstract repository interface using a Postgres database. So this Postgres mock repository implements abstract repository. Then there's an init function which initializes the database, that is the connection, starts the connection with the host database user and password, creates the connection, gets the cursor, creates a table called books with ID, title, and author, inserts some data into the books, gets some data from the book, and removes. So in this one, I have used a different example, that is a books table with ID as the primary key, column, title, and author. You can also use that previous example with chocolate boxes. This is just a different example that I'm showing here. Now, in the add, it just executes this SQL statement and commits it. You can also use SQL Alchemy here. But yeah, and then in the get part, we also execute this select statement. And then if there's a row which comes back for that ID, we return that row, else we just return none. And for remove, that row is deleted for that book ID. So in this implementation, we use the psychopg2 library to connect to a local Postgres database and define a books table to store our book entities. The add, get, and remove methods are implemented to interact with database SQL queries. This implementation is still a mock repository. We are not using a real Postgres database. However, it could easily be used to create a real database by changing the connection details in the constructor. Why create mock repositories for integration tests? We create mock repositories for integration tests because integration tests are meant to test the interactions between different parts of the application. However, we don't want our integration tests to depend on real database or external services, as this can include flakiness, slow down tests, and make them harder to debug. By creating mock repositories, we can simulate a real repository's behavior without hitting the database or external services. This allows us to test the interactions between different application paths in a controlled environment without worrying about the external factors that might affect the tests. Here's an example of how you could create a mock repository class for integration testing in Python. So this mock repository implements abstract repository. It has this init function with an empty list and has these add, get, and remove methods, which just uses an in-memory data list dictionary and just adds, gets, and removes data from it. So it just stores the data as a dictionary that's local to the class instance. By using mock repository in our integration tests, we can simulate the behavior of a real repository without actually hitting the database. For example, we could write a test that checks if an entity can be added to the repository and then retrieved. Test add and get entity, mock repository. So entity equal to chocolate box of ID1 and name test. Mock repository dot add entity. Retrieved entity mock repository dot get of 1 and assert that the retrieved entity is equal to the entity that we passed in. So in this function, we're using mock repository as a fixture that's passed to the test function. So fixtures again are really important. If you haven't looked at my PyTest video, then I would suggest going and looking into what fixtures are in PyTest. Generically, it's just something that you pass into the test function. So we are adding an entity to the repository with add and then retrieving it using get. We are checking that if the retrieved entity equals to the original entity we added, this test checks if the add and get methods of the repository are working correctly without hitting the database. Great. So now that we looked at a very simple example, let's take a look at a complete code base demonstrating how to use an abstract repository layer with mock and in-memory implementations. The code is split into several files, with each containing a different part of the application. So there's a book.py, which defines a class book with an init function, which has these three parameters: ID, title, and authors, which initializes the instance variables for the book's ID, title, and author. Then we have the abstract repository, where we define the abstract repository class, which implements this ABC abstract class from Python. We have these decorators abstract method, which show that add, get, and remove are abstract methods that need to be implemented in any concrete implementation of this abstract repository class. Now we have the mock repository, which implements the abstract repository class, so it must have the add, get, and remove methods. We see that there's like a data dictionary which is empty. Then just adds a new entry to the dictionary. Get retrieves that entry based on the ID, and delete removes that entry from the book dictionary based on its ID. Now let's look at an in-memory implementation. Initializes an empty dictionary, added a book object to the dictionary, retrieve a book object by its ID, and removing a book object from the dictionary. That's it. Now let's look at the app.py. So create a book which takes in repo as which is of type abstract repository. So this is type hinting for the parameters, which is very important because Python again doesn't define what kind of inputs you are taking. So if these kind of hints are there, it's easier for people to understand, otherwise they might get mixed up. So the repo parameter takes in an object of type abstract repository, ID takes of type int, title string, and author string. This creates a new book instance and adds it to the given repository, which has parameters repo, ID, and title. This is also very important when you write functions. Make sure to follow good coding practices and mention the parameters and add doc strings. So book creates a new book object and adds repo.add, adds that book to the repository. Get book takes in two arguments, repository and ID. So retrieves the book with the given ID from the repository. It defines the params and also shows the return type of this. So return repo.get ID, which retrieves the book with the given ID from the repository, and delete book takes in the repository and the ID. So if book equal to repo.get, if the book was found, then remove that book. So remove that book only if that book was found with that given ID. So now if you want to test this, define a function to test the mock repository class. Repo equal to mock repository, create a new book object with these ID1, title test book, author test author, create a book, that is add the book to the repository using the create book function, check if that book can be retrieved from the repository using its ID, so assert get book, repo book ID, delete that book from the repository with the delete book function, and then assert get book should be none. So after deleting, the book ID should be none. And similarly for the in-memory repository, which is basically the same as the above. So to execute this test, you need to run pytest in the terminal from the root directory of the project. Make sure all the files are in the same directory of the package or structure. In case you don't have pytest installed, you'll have to do a pip install pytest in the terminal. So a quick overview of all the files and why they are being used. So book.py creates the book class and defines a constructor to initialize ID, title, and author. Abstract repository defines the abstract repository base class, which defines the abstract methods add, get, and remove. Mock repository defines the mock repository class, which stores book entities in memory. Similarly, in-memory also stores chocolate entities or book entities in memory. App.py, this file defines the main application logic, which has three functions: create book, get book, and delete book, which uses the repository functions to create a new book entity. So when you have an application, you will not have people interacting directly with the database, right? You will have some application layer. So that is what app.py is. It is responsible for being an interface between the database and the user. So the user will be calling these functions which are in the app.py, and you inside that app.py function will be adding calls to the database to do things. Test app.py defines the integration test for our system, creates the create book, get book, and delete book functions using both mock repository and in-memory repository. The next step here would be using a Postgres database to implement both in-memory and database repository functions. So both should be running simultaneously, and the test should be passing for both these repositories for us to be able to ensure that, right, all of this is working. So that we will be doing in the next video, maybe a part 2 on this. So coming to the conclusion, abstract repositories are an essential design pattern for building robust, maintainable applications. They allow us to decouple the business logic of our application from the details of how the data is stored, making our code more modular and testable. In this article, we explored the concept of abstract repositories and looked at an example implementation in Python. We also discussed how abstract repositories could be combined with mock repositories and in-memory repositories for testing. By using abstract repositories, we can build more resilient applications to changes in data persistence technologies and easily switch between different storage mechanisms. This design pattern can help us build more maintainable, scalable, and testable applications. If you're building an application that needs to store data, abstract repositories are an essential tool to consider. They offer a powerful way to separate your business logic from your data persistence concerns, making your code more modular, testable, and maintainable. That's it for this article. Feel free to leave feedback and questions in the comments. If you found this an exciting video, like and subscribe to my channel, Python Code Nemesis. Thanks for watching.